The Discord looks good. I'm refreshing. I'm refreshing Twitch. Yeah. Are you gonna use your other machine too? Yeah. 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 I think it's worth cranking up to 60. All right. You want to get started? It looks like the stream is good, so we'll do that. Yeah, I'm Matt Oswald. I work on the Antidote platform, which is an open source project that sits behind all of what we're talking about today, and what we talk about on these streams. Um, and I have a few cool things that I'd like to talk about. One of which is I actually have been working a lot on improving our documentation, which has been suffering over the past few months since release. It was great when we launched it, but these things tend to stagnate over time. So I'm working on those. I want to share an update on some conceptual diagrams that I think will help. Actually, with the conversation that you just touched on, Derick, like the relationship between NRE Labs and Antidote and all of that stuff. So I think that'll help. And then there's another tool that the savvy among you probably already know about, but we haven't really done any marketing around it. Like we haven't talked about it. Um, because of a few things, and that is the validation tool for syringe, which is one of the back end components, and I'll get into what that means and why you care. But before I touch on any of that, what is there any from a community perspective, Derick? Is there anything you want to touch on before we dive deep into the weeds? There's a spot missing, dude. There's a spot missing. That's so dope. No, it looks good. It's. I think it might just be backwards for you. So that if so yeah, I think Discord does that for the mirror effect. The toad is in his natural habitat, rummaging around his office for things. Oh no. I can't make sense of that, dude. I don't know what I don't know how big a quarter is. I need a banana. Like I need you to put a banana next to the sticker. It's not helpful. What But you've done the research and you understand the reference now. Okay, good. No, not at all. But it's a little funny though. 700. Nice. Was it on last week's stream that we were talking about doing something like patches? I can't remember when we talked about that.
We're gonna if we're not careful, we're very soon we're gonna have a lesson on tabs versus spaces. Like that's what the lesson is gonna be. It's gonna be two people contributing, arguing with each other over code, and they're just gonna commit the result. We're gonna have to learn from it somehow. You're not wrong. One, oh yeah, yeah. Yeah, I'm really torn though, because like I used to be exactly like that when I wrote exclusively in Python. It made perfect sense. But then like Go standardizes on tabs in the tooling. If you run GoFumped, yeah. So uh, it's fun. It's fun. Yes. Yeah, yeah, that's fair. In fact, I can answer that last one pretty easily. There's been a my review for a while, and I actually have made a good dent in one of them because they're all fairly large. I just haven't finished yet, so I'll sort of highlight what's been done and what's currently in progress, and effectively just reiterate that I'm working on getting them merged. But before that, let me share my screen. I want to show a diagram very briefly. For those that have seen me present on NRA Labs, you've probably seen something like this. I just modified it briefly because in lieu of a more, I literally just hacked this existing diagram into place to show what I wanted to illustrate, and I'll be putting something a little more formal looking on the docs. But basically, I wanted to highlight the relationship between the curriculum and the platform. So when Toad talked about how we've open sourced all of the tooling and all of the software um, behind what makes NRA Labs work, what he's referring to there is these platform elements. We have a piece of software called Syringe, which sits behind the scenes, doing things like scheduling lessons. So when you call up a lesson, there's actually an API that gets called, and that API belongs to Syringe. And then Syringe says, okay, well, it looks like you're looking for lesson 11, and I see in the lesson definitions I've been configured with, I see that lesson 11 requires 3 VQFXs and a utility container, and it needs to be configured this way, and there's all kinds of lesson details that are in those lesson definitions. And what it does is it turns around and it pushes it sends API calls to Kubernetes to make all of that stuff work. So that's what Syringe is. And then Antidote Web is effectively what you would expect in a traditional like HTML, CSS, JavaScript web front end kind of application, with a slight modification that there's a little bit of Java behind the scenes that runs in a servlet. You don't see that, but it's what's required to make the SSH terminal that's in the browser, Guacamole. That's what's required to make that work. But the vast majority, vast majority of the logic is all front end JavaScript, and then your typical HTML and CSS stuff. I think there's like 20 lines of Java. I wrote as little Java as possible as was required by the project, Guacamole. So most of that stuff's in the front end. Anyway, those are the two components. I mean, there's a few other like really smaller components that we use from a platform perspective, most of which are optional. Like we do some like TSDB stuff like with Influx, but like that's not required for the platform. So the main two components are here, Syringe and Antidote Web. So when we talk about the platform Antidote, what we're talking about are these two components. We use this term Antidote to describe the open source platform that sits behind the scenes. It's really an umbrella term. It's meant to encapsulate anything that goes into this platform that makes the platform work. Now, you'll notice that the curriculum is actually a separate tier to this. And I spoke about this in the Network Field Day presentation I did where I showed these slides a few months or two ago almost, at least a month ago. Where I highlighted the fact that the curriculum is actually separate. What we've done is we've disaggregated the curriculum so that it's not baked into the platform itself. And I wrote a blog post on this well over a few months ago, a few months before NFD, in fact, talking about the idea of doing curriculum as code, which sounds super buzzwordy, but it's actually true. What we've done is we've taken the abstraction that's offered by Syringe and allowed folks to describe lessons in simple text files. So there's a YAML file that you use to describe a single lesson. And then there's a whole bunch of other files that are required based on what you have in the lab. Like for instance, you'll need a lab guide, which is a markdown file. You'll need some Junos configuration files if the device that you're configuring is Junos, of course. Things like that. So there's a bunch of things that are required in those lesson directories, but they're all text files. There's no like database that you got to interact with or GUI that you got to drag and drop things around. It's all stored in Git. And the cool thing about that is what we've done is we've put up in the Antidote repository, we've put up a set of lessons, and every lesson that you see in NRE Labs is in that directory. And what we're doing is we're calling that NRE Labs. That's what NRE Labs is. It's a directory that contains all of the lessons that you see in NRE Labs. Because really, what this is NRE Labs is really a curriculum. Yes, it's a website, and it's sort of the canonical it's the way that we're proving out these concepts. It's the sort of the golden showcase, I guess, of the Antidote platform. But it really is just that. NRE Labs is really just one curriculum that's possible. You could build your own totally separate curriculum with its own resources and own lessons and own collections and all kinds of stuff like that, and just simply put it into the space that NRE Labs would normally fill. And it's built into Syringe to allow you to do that. And so I want to highlight that because we're going to be actually moving some things around. It'll be, if you're using NRE Labs, it'll be transparent to you. If you're contributing to NRE Labs, it'll be a little different, but it won't be that bad. Where we're actually going to be giving the NRE Labs curriculum its own repository, because right now it's sort of sharing a repository with a whole bunch of infrastructure tooling and stuff like that. So we'll be moving things around, and this is way in the future, weeks at least. So we'll be sending out some detailed information on what's moving where. That way, if you're working on a PR, or for instance, for the curriculum, you'll know what to do. But this is what's been on my mind a little bit. I want to move these things around a little bit so that they make a lot more sense with how they actually work in the real world. Yeah. Yeah. Yeah, you're right. Yep, that's right. So just VMs. So we're actually just maintaining our own cluster. Yep. Yeah, that's correct. Yeah. Yeah, I mean the way that I would talk about that is like if you're using something like a story, it becomes a little easier because you don't have to automate joining. When you scale up a cluster, you don't have to automate, you don't have to do anything yourself by virtue of automation to join those new nodes into the cluster. It's all handled for you. Whereas in this realm, you kind of do because GCE doesn't have any opinion on how the VMs are actually configured. It just has an opinion on that they exist and that they're sized appropriately. So that could be automated. You can say certain things like, hey, if my if my CPU goes over a certain a certain amount for cluster wide. And I mean cluster just like a cluster of VMs, because again in GC it doesn't really know that you're running Kubernetes. Um, if you can do that and say like, hey, I want to scale up to a certain point. I would like to scale up if you see that you're over a certain percentage in terms of CPU utilization. There's a few other metrics you can use. The caveat there is that you have to automate the joining of those new nodes to the Kubernetes cluster, because again, it's not a managed offering. You're just running VMs, and so if you wanted to do auto scaling, you'd have to automate that portion. It's doable, but the way that we're working right now, actually, and this is one of the reasons we're doing this, is because we may or may not move to GKE in the future. So we're just sort of keeping things fairly static, just so that we don't have to like invest time in automating something we're just going to throw away in like a month. So right now, what we do is we just manually create massive VMs. I think we've got like 32 vCPUs and something like 64 gigs of RAM per host. So the number of times we have to like actually scale up the cluster is not very frequent. Yeah, that's exactly right. In fact, I can show you. So this is the -n. See that -n is for the namespace. So in our Kubernetes cluster, and this is what we recommend people do if they're deploying it themselves, we have all of the pods deployed within namespaces. So the prod namespace hosts the production instance of Antidote, which is what you see when you go to Nerdery Labs. We've got an Nginx ingress controller, which monitors all of the ingress rules across the cluster and makes changes accordingly and routes web traffic accordingly. So that's actually what you hit. It's actually the second load balancer you hit when you go to the site. The first one is a Google load balancer, but that's mostly a pass through. The way we have that configured is just simply send all traffic to the Kubernetes cluster, and then the next thing that receives the traffic is this ingress controller. And then, like I said, we have some optional things here like Grafana and InfluxDB for some stats tracking, but that's not required. The system will still work without that. But yeah, to your point, we've got Syringe running in a deployment, and we've got Antidote Web running in a deployment. So these are the actual pods that are being hit when you look at the site. Mm-hmm. Yeah. Basically, yeah. Correct. The real difference between them is that a pod doesn't just have. It usually does, but it doesn't have to. In fact, all of our pods, if you look at the Syringe pod, for instance, this is a pretty common way of doing this. And I think instead of get, let's do a describe. You'll see that there is one container here called Syringe. And you can see that it's configured with a bunch of environment variables, just like you would be able to do like if you're running Docker locally. And the image that's running is Antidote Lab /Syringe, and then of course the release tag, because we're doing things in a CI/CD kind of fashion, which is good. So that's all expected. But if you go above that, actually, you'll see git clone. This is not required, but this is the way that we actually get lesson content into the pod that runs Syringe. So the very first thing that happens when you start Syringe in Kubernetes, at least if you deployed it the way that we deploy it, which is in the repo, what it'll first do is it'll actually clone the Antidote repository, which is where the current curriculum is. Like I said, we're going to move that probably in the near future, but that's where it is right now. And then, of course, check out the specific version, because again, everything's versioned. And then I want you to, and then it clones it to a specific directory inside the pod /Antidote. And that's why when we go here down to the actual Syringe container, we're specifying the Syringe lesson repository directory as /Antidote. So the first. Yep. So the first container is responsible for just running a git clone and getting all the lesson content stored locally. And then when Syringe starts, it's configured to look at that location for lesson content, and of course it'll be there because git clone took care of it. Yeah. Yeah. Yeah, sure. So and I think this is actually a really good segue and how behind the scenes and makes everything work. I mean, the web front end is cool, but the if we were to point to a thing and say like this is the brains of Antidote, like it would definitely be Syringe. The vast majority of the logic of how everything works is in Syringe. Um, so as a result, when you're talking about from an architectural perspective, you look at the different components of Antidote. In fact, if you go to the second slide, you can see it broken down a little more, where you see all of the API calls and all the HTTP traffic being sent. Like it looks a little confusing, but if you think again, if you realize Syringe is really the brains, it has in memory all of the lesson definitions, and all you have to do is request a lesson via API, which again is all handled for you in the front end, so you don't have to actually do that if you're a user. But you send the API call in, and it says, "Hey, I'm going to spin up a lesson," and all these things happen. It has fairly strong opinions on how those lessons should be formatted. What we actually do behind the scenes is you can see that we're running gRPC and then REST on top. A very common way of deploying REST APIs, at least these days, within a Go based application is to define that API as gRPC instead of REST. And so like it's not always that way. Like there's a lot of folks that just build REST only APIs for Go applications, but an increasingly popular way of doing it is to build your API in gRPC instead, using something called protobufs, which we'll get into, and then use a small sort of project called gRPC Gateway to effectively proxy between HTTP and gRPC. That's exactly right. In fact, and this again, not this is kind of optional, but there are projects to automatically generate Swagger docs from that resulting API, which is something something we're also doing. Um, we haven't published them, but if people want to integrate directly with the Syringe API, certainly that's something we can look into publishing. It's just something that if you want to see the Swagger docs, you certainly can see them. You just have to compile Syringe yourself. We haven't published the result of those docs anywhere. Because again, the vast majority of people don't really integrate with the Syringe API. They call it via the web front end that they're simply interacting with. But we'll see. We'll see if there's interest there. Certainly, the tooling exists. So anyway, the reason I bring all of that up is not about this horrid, like super confusing looking diagram. I just wanted to call attention to the fact that everything in Syringe is modeled. So when you talk about things like lesson definitions, and I'll just bring the next slide up, you can see this is a lesson definition. Yeah, it's an image. I'll just go to a real one. There we go. Okay, that might be a little too big. So if we go to, let's see, lessons, lesson 12. I love to pick on lesson 12, the first one in the directory, and I know that it's the JSnappy one by memory. I don't dream about Nerdery Labs at all. A little better. So this is a lesson definition. So it's just one. This is just the actual lesson definition for the JSnappy lesson. You can see that there's a lesson name, lesson ID, category is tools. It's the category that we're working with at the moment. Optionally, you can specify a lesson diagram. There's a whole bunch of other metadata you can specify. And then inside the lesson, you also want to specify things like what kind of endpoints there will be. There will be utilities, so things like little Linux containers that have tools that you want to execute, scripts and things of that nature. Devices, so these are our VQFX devices. The difference being what Syringe will actually do for devices, as opposed to anything in the utilities section, is it will use Napalm to attempt to configure those devices for each lab that you go to. And so as a result, in order to know how to do that, there needs to be in the lesson directory here, stage 1 configs. You'll see vqfx1.txt, vqfx2.txt, and so forth. So all of those things need to be there. Each lesson guide. Oops, I lost where I was. Shoot. There we go. Each lesson guide is here as well in each lab directory. And you can also see that there are a few other files in the directory required, but they're just part of this lesson, so you can put them in there. Again, the cool thing about the way that we've built this in the back end is every pod that we spin up, we clone the entire lesson directory into that pod. And so if you wanted to interact with something in the lesson, you just simply put it in the repo, and it'll be made available to you at runtime, which is pretty cool. So anyway, it all starts with this lesson definition. So everything that you need to declare a lesson definition is starts with this syringe.yaml file. Now, it's not just limited to that. For instance, like I said, there are a few things here that are not required, like tags. That's actually not a required field. Lesson diagram, also totally optional. You don't have to specify that. However, lesson ID is very much required, as is the lesson name, and there are a few other things that are required. And then there are a few other kind of second order requirements. Like for instance, this is one thing that I made sure to validate for recently. If you have devices, not all lessons have network devices. Some of them are just simple Linux containers that you use to learn how YAML works. So not everything has this. So having devices isn't required. But if you do have devices in your lesson definition, then you absolutely need to have configurations for them. Because again, what Syringe will do in between every lab is it will see, oh, I have a VQFX1. I need to go look in the current stage that's being activated, stage 1, and look for a config that equals that name, VQFX1. And if it doesn't exist, it'll just puke because it needs a config. It needs to have a config to work. So anyway, that's sort of like a second order requirement, and it's not super intuitive. I mean, you can read the doc, but A, the docs are currently out of date, as I mentioned at the beginning of the call, and B, it would be nice to just have a tool to just do a quick health check, like a quick validation of your lesson content, as opposed to just going, reading through the doc and hoping that you followed everything correctly. So, what we've done is, if you look at the Syringe repository, I'll show you a little bit behind the scenes, but this is not something you need to know to run this. We defined everything in protobuf. So if you look at the lessondef.proto, you can see the lesson definitions fields are all here. And we do some basic validation here, like for instance, the tier field. It has to be one of these three values, local, PTR, and prod. There are a few other things like minimum length has to be at least 10. Things like that. That's really easy to validate. We're using a project that Lyft built, incidentally, to do that. So that's pretty cool. But beyond just that simple validation, we're also doing those other validation steps, like making sure that every network device that you specify has a corresponding config for every lab that you want to spin up. That's not something we can capture here. We have to actually write code to validate that. And so we have this huge validation function in the actual code of Syringe to do all those checks. So I bring all that up just to show you sort of how we've done it. But the point of that isn't to know how to do any of that. We've actually compiled all of that into a tool. So if you look at the two components that are built into Syringe, you have Syringe D, which is the actual server that runs in production that actually powers NRE Labs. And when it starts up, it looks at the lesson directory and calls out to that validation function and says like, hey, the lesson directory I'm configured to point at right now, go ahead and import all of those lessons. And as a result of the import process, it'll validate them as well. However, running the server version of Syringe isn't something you normally would want to do on your laptop because you'd have to configure a whole bunch of other stuff. Point me to Kubernetes, point me to a whole bunch of other things that you need access to in production. What would be cooler is if we could run that same validation logic locally, as opposed to requiring like the whole server deployment that Syringe D requires. And so we've had this tool called SYRCTL for a while, actually. But again, there hasn't been a lot of usefulness outside of really me, just because mostly what SYRCTL has been doing is managing the state of Syringe. So it's more of like a behind the scenes tool for me. Or anybody else that wants to run their own version of Syringe. However, it's a fairly simple application. Like it doesn't really do all that much and doesn't require a lot of knowledge to run it. It doesn't require any of the configuration variables that Syringe D requires. It just kind of runs on its own. And so it made sense to add a command into SYRCTL that allowed you to perform that same validation logic that you would normally need to run on the server, but on a simple command line application that you can download onto your laptop. And again, it doesn't have any dependencies because it's precompiled and it doesn't require anything from a configuration perspective. So if we look at the lessons directory here, as I mentioned, all I have to do is type syrctl, validate, and then the lessons directory. And as you can see, it imports all of the lessons in that directory, and it says all detected lesson files imported successfully. So you have confidence. Let's say this is let's say you forked the Antidote repo and you're working on a contribution. You want to know that your lesson was imported successfully without errors. And so you'll be able to see that here. You'll see that, hey, look, all the lessons have imported correctly. Now, of course, this is the master branch of the Antidote repo, so everything should be working successfully. Let's say you're this is all totally offline. The syringe D, the actual server portion of this is not in the picture. It's not required at all. It's just running the same validation functionality that the server side daemon would normally be using. So let's say if you want to like say let this, I just deleted one of the configurations in the JSnappy lesson. If I rerun this, you'll see that it said, hey, I imported 14 lesson definitions. What'll happen actually in the validation logic is it won't just crap out. It'll just skip a lesson that failed to validate. That way, when we're running in production, we don't have to have everything perfect. It'll just simply discard any lessons that fail to validate, and it'll continue to start with the lessons that successfully validated. But you can scroll up and you can see the outputs. It says, hey, configuration for device VQFX1 for stage 1 was not found. And I should be outputting the lesson that failed to validate. I should be showing that to the user so that they can see that. But you can see that there is an error, obviously. And of course you can see that lesson 12 is not listed in the output of successfully imported. Sure, yeah, that'd be cool. Yeah, just so I don't forget, because the debug is there. It's just it doesn't show you what lesson. So that's super helpful. Okay, hopefully I'll remember what that means. So anyway, the reason this is valuable, let's say you go down the path of like working on trying to contribute a lesson. Very often, what'll happen is like and of course we still have self-medicate. We talked about that on the first stream. That's valuable. This isn't meant to replace anything that self-medicate does. The problem though is that in order to know that a lesson has failed, you absolutely have to spin up self-medicate, which again you totally should before you submit a pull request. But when you're very early on developing lesson content, it's a little much to have to spin up self-medicate like right away before you even really get started. Because again, if you don't have any other way to know that your lesson is valid, it's kind of your only option. What would be cool is if you had a simple tool like this for the very early portions of your lesson. You just starting to put the lesson definition in place and put the right configs in place, and you just want a basic check as to what's required. Maybe your lesson guides aren't written at all, but you want to know like that you've put the lesson guide, the blank lesson guides or bare bones lesson guides in the right place at the very least, or that you have the configs in the right place at the very least. This is a cool tool, I think, a valuable tool for early on in that contribution lifecycle. Because and I think the real point, the real reason for that is it's very lightweight. It doesn't require any dependencies. You can just download the precompiled version. You can compile it yourself if you want, but a lot of people don't want to do that. So you can download the precompiled version and then just simply that's it. Yeah, sure. Just one. I want to touch on one thing real quick. That is how to get. Oh, sorry. I just want to touch on one quick thing, and that is how to. Okay, here's how to get SYRCTL. Did I get it? Okay, that's just one thing I want to touch on. So if you go to the syringe repository, and this will be something that we link to in the docs. But if you go to the releases section here, what we've done is we've incorporated. I've built automation into our release process. I spent a lot of time over the last week enhancing the release process for Antidote, and one of the enhancements I made was compiling syringe for every release, and then uploading those compiled versions to the actual release itself. And so all you have to do is go to this page, go to the latest release. I think this actually has a link. Yeah, syringe/releases/latest, and find the platform for you. So if you're running a Mac, it's going to be Darwin, like AMD 64. Do like zip or tar.gz, whichever you want. They're identical. They're just different archive formats. Or if you're running Linux or Windows, we have other formats we can upload, but these are the common ones. So if you grab those, there are two binaries in each of those. Syringe D, which again you can use if you want, but that's not really, it's not required. You can delete it if you want. But SYRCTL is also in there. Put that in your bin directory or anywhere else you want, and then just simply run it. Cool. So off with your questions. Okay. All right. Yeah. 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 Yes, that's correct. Yeah. I mean, certainly that's something we could check. Think I'm, but I don't know for sure. Let's give it a try. Git checkout. Let's get our lesson definition back. Actually, our config. And then you said change less than 80 to string. Yeah, looks like it puked on that. Basic validation failed. Value cannot unmarshal. Yeah, it needs to be in it. Yes, yeah. So if you go to, yes, that's correct. I don't have to explain if you don't want, but yes, that's correct. Yes, that's just a string. Yeah, I don't go into detail on that, especially considering whatever you put. Oh, certainly. Yeah. I mean, the first, like, you can think of it as like three stages of validation. The very first is just basic YAML. So we're using the standard library, YAML parser in Go to just simply import all of this content from a YAML perspective into a Go struct, which is actually automatically generated because of the way we're doing protobufs. But basically, that's the first step. Like, it needs to be valid YAML for sure. The next step is field based. From a field perspective, we've decorated each of those fields, not all of them, but a lot of them, with certain things like you need to be an integer, or if you, or even more than that, you need to be an integer greater than X, something like that. So that's like the second layer of validation, and the third one is the more deep validation, like I showed you before, where we deleted the config, and the code behind the scenes says, "Hey, you need a config for this stage." That's anything that's like really syringe specific. We check for at the last step. Yeah. So that's actually a recent change. If you look at the syringe repository and you go to closed pull requests, I removed the requirement to specify the subnet for lesson definitions. The reason for that is the subnet, having a subnet in the field. The reason we had that before was we're actually passing that into the CNI network configuration. So the way that the networking works in Kubernetes is via a plugin, a CNI plugin, and it requires a subnet to be specified in that field. I'm trying to figure out where I changed the actual configuration. I thought it was here. No, you do have to put a subnet in the actual CNI configuration. Well, previously you did. Like I said, I wanted to expose that field into the network configuration. But to your point, from a lesson perspective, it's not really required. It's just required because we at that time were passing it through to the network configuration for CNI. So in this PR, what I did was I basically just specified a static subnet to be used for everything. And the reason we get away with that is because that subnet's not actually enforced at the CNI layer. And I think this might be a little bit plugin specific, but because we're using the Linux Bridge plugin, it's not actually enforced that subnet's actually used. So even though you specify, I'm specifying something like, I don't know, 10.0.0.0/8, something like that. Behind the scenes, it doesn't matter because it's not actually like enforced from a firewall. It's not like filtering only on that subnet. You can still specify any IP you want on the actual devices, like your VQFXs and whatnot. And so it's just taking one more thing out of the requirement to be specified in the lesson definition. Yeah, that's exactly right. Yep. The answer is I killed it. It's not going to be a problem for us anymore. Yep. Mm-hmm. Yep. Yeah, and to be clear, there are a few things that it doesn't. Configurations are correct. We might, we could maybe build some basic parsing in there, but at the end of the day, like you're still going to have to run this in run your lessons in self-medicate to make sure that things are pinging and like the configuration is where you want it to go. It's going to need to, you're going to need to use that to make sure things like line up visually and like all kinds of stuff like that. So there is a limitation to what this will validate, but like I said, I think early in the process, it's super valuable. You don't even have to start self-medicate right away. If you're just launching into starting, building one lesson, don't even bother. Just start to assemble the files and use this syrctl validate command to light your path as you continue to go down there. And once you have a valid lesson, start self-medicate and start putting the finishing touches on it. One more thing I just want to touch on. So SYRCTL itself is just is really a command line utility. Hello? What? Discord closed. Yeah, it just closed. What was the last thing you heard? Should be. Hold on. I don't know what happened. Oh, so SYRCTL. Just to reiterate, SYRCTL is the command line utility for basically any contributor to Antidote. The validate subcommand is just one piece of functionality that we've built into it. Like I said, there are other subcommands that have existed actually for a couple months. They've really just mostly been useful to me, so that's why we haven't really talked about SYRCTL that much. However, now that we have this one use case for doing things beyond just like what I want to do, like the validate functionality is very useful for contributors. We're thinking about other contributor functionality that we can introduce into this tool. Now that there's at least one use case, we're going to be building other cool things into it. For instance, maybe an interactive wizard for building new lessons. Like if you just want to like go through an interactive wizard and supply some information via like an interactive like prompt, and have it automatically generate like all of the files and lesson directories that are needed to start a new lesson. That way you don't have to create it from scratch or copy from an existing example. That's something we're thinking about doing too. So basically going forward, don't think of SYRCTL as just simply a way of doing validation, because that's just one subcommand. You can think of SYRCTL as like your friend through the quest of contributing to NRE Labs. And we're going to be building more functionality into that as time goes on. Sweet. Nonsense. We I know we both have one at 11:30, but I don't know about the half hour in between. Sorry, I mean 1:30 your time. Yeah. I'm used to you being on the West Coast, man. You've been on you basically moved in last week. Yeah. I don't think so. I can just really quick talk about the other things that that have been done in the past week. The Yes, yeah, do that. That's better. Yeah. That's funny you brought that up. I didn't think so, but we had some folks internal to Juniper that were using self medicate. They ran into some issues with the latest, like very latest version um, of Minikube, and they were reporting that they fixed it by going back to the version that I happen to be running, which is 0.34.1 is what I'm running, and I think they're running 35. Okay. Yeah, and I would say if you're running into issues with Minikube, definitely make sure that you have the latest version of the repo. We definitely need to do better about communicating when there are Minikube changes, or when there are self medicate changes. But the very first thing you should do is if you're having problems, check to see if there are commits to that repo, because usually when we fix something, we push it right away. Um, and so it helps to have the latest version of self medicate. In the future, we're going to be versioning self medicate, so we know that um, the existing releases are more or less stable. But we're not doing that at the moment. We need to. That's creepy. That's that's my wife. Say hi to the stream, wife. Oh, she's good. She's good. She she's come down with a case of the interruptus. Oh, that's funny. She's got my 7-month-old daughter downstairs, so anytime she wants me to stop, she just brings her up here, and I'm just like, okay. Yeah, yeah. Discord is I haven't used it in quite like about a year, just because that's when I was back into like more competitive gaming. But it's a cool application. It's way better than Slack, in my opinion. See you later, everybody. Thanks for watching. Yes.